Yep.
Okay, so when I look at a valve like this, the first thing is normally we don't see the cutaway, right?
Right, yeah.
So when you walk up to a valve, you see this valve, this big, you know it's a hydraulic control valve. You know it's got a bunch of piloting spaghetti on it, and you're like, holy cow, what does this all mean? The first step in understanding a valve, because immediately by looking at it, you can't always tell which way the water's flowing. So I always come and I look at the outside of the valve, and I look at the line on the back.
Oh.
And you'll notice it's got an upside here, and then the line comes across, and then it goes down on that side.
Okay, yeah, in the casting.
So, in
I
the
see that,
casting, yeah. So this is the upstream side, this is the
Oh, okay.
downstream side. So as soon as I have that, I know that this is high pressure and this is low pressure.
Sure.
Okay, so that's just the first start of me, because what that does then is it allows me then to start tracing the path of the water moving through the piloting.
Oh, yeah.
So
Makes sense.
I know that how this valve works is that this piloting, this mess up here, all that whole purpose is to add water onto the top of the bonnet, which forces this valve to close, and in the process of closing, restricts or causes a restriction in the cross-sectional area of flow, which increases the head losses. Now that does not affect the flow rate, okay? It only affects the pressure losses or the head losses across the valve.
Okay.
So conversely, when the cross-sectional area of flow gets low, the velocity gets high, we still have the same amount of water going through. When velocity is high, we have high head losses. Now the other option is this piloting can let the water off the top of the bonnet chamber, which allows this valve to open, which then allows the disc to come off the seat, which increases the cross-sectional area of flow, which allows the velocity to reduce, which then reduces the head losses.
Okay.
So the whole purpose of this valve is not to control flow rate, but to control pressure, okay? Always to control pressure. There are certain valves, hydraulic valves, which are designed for flow control, but they're not as common, okay? So, and they're usually associated with pump start and stopping. Okay, so, but that's not us, okay? So these valves are all about controlling pressure. So so if I look at the back side here, so again, this is my upstream side, so it's my high pressure side, this is my low pressure side. So I know that my water is always going to flow from high pressure to low pressure. So that means the water's coming out of this port here, my high pressure side, and it flows up through the restriction valve or the dole valve, and then it's got two directions that it can go. It can go up through the needle valve, through another stopcock here, and then onto the top of the bonnet, or the water can go and travel further through the piloting, pass through the CRL valve, pass through the CRD valve, and then pass out down to the low pressure side. So that's the choice. Now you'll notice here I've got this extra line which I haven't talked about, okay? So this line is not a line that water can flow through. All this line is a pressure sensing line. So it transmits the pressure into the pressure sensing chamber on the CRD. That's its whole purpose. So the CRD will be open or closed based on what pressure it's sensing down here, okay? But before I get talking about that for a minute, so the water comes through, it goes up and around, passes through the dole valve. So all the dole valve is this nut here. It's basically a flow restriction valve, and it's going to let through, let's say, 0.1 gallons per minute, okay? And that's all its purpose. That's it. It just says, doesn't matter what's happening upstream, pressure changes, goes up, goes down.
Constant.
You get 0.1 gallons per minute, okay? Now, if this valve here is closed, it's going to force that 0.1 gallons per minute onto the top of the bonnet, all of it. It'll just like, you don't have a choice. You're going to go on here, okay? Now, this second valve here, it doesn't matter whether it's opened or closed if this one's closed. If this one is closed and controlling it, this one could be, I'm going to do lots of different things, and it's basically like a person in the background yammering at you. It doesn't matter what it wants. This one's the dominant valve, okay?
Right.
So when you're looking at piloting, the valve that's in the front or the upstream valve always has priority over control of the main valve, okay? So the conditions for operation of this valve, this pilot valve, will control this valve first, okay? So now this valve, the CRL here, is set up in a sustaining function, so pressure sustaining. It wants to make sure that our upstream pressure doesn't drop below a set point, okay? So maybe that's 100 psi or something, because this is still a pressure reducing valve. This valve, as the water passes through it, is going to reduce the pressure. Now, that will it will allow the water through this valve as long as the upstream pressure remains at a set point. Now, we use this when we want to maintain upstream pressure, say for fire flow conditions, that our neighborhood needs a minimum of 40 psi, and we don't want it to drop beneath that. So this valve here, the CRL, will close this valve if you drop below the minimum pressure that it wants to maintain in this neighborhood. And it says, regardless of what the downstream people want, I don't care. You don't get it. I'm going to make sure that the upstream people keep their pressure that they want. So let's say it's set at 100 psi, and or this valve is set at 100 psi, and if your upstream pressure is above 100 psi, let's say it's 120 psi, that 120 psi is transmitted into this chamber here. And if you guys have looked at the inside of the CRL, you'll notice it's got a valve sensing pressure chamber here. And so basically that pressure is submitted to the underside here, and it basically fights against the spring here. The spring wants to push the stem down, the pressure wants to push it up. So, and because this is a normally seated valve, when the pressure is higher on the bottom than the spring pressure is set at, so the spring pressure will be set at 100 psi. If you've got 100 psi going into the valve sensing chamber, it will overcome the spring force, lifting the stem, which lifts the disc off the seat and opens this valve, right? Hey, we're open. So we're feeling pretty good about that. And, sorry, just thinking of coughing there for a second. So it lifts it up, and then this valve stays open. And when this valve is open, it allows all of the pilot water, that 0.1 gallons per minute, to just pass through it. So as long as the upstream pressure is above 100 psi, this valve acts like an open piece of pipe. It does nothing. It doesn't try to regulate downstream pressure. It doesn't care. It just says, you've met my operating conditions of being bigger than 100 psi. I will remain open. And so in that case, we've met the operating conditions of the CRL. So now the CRD can start to regulate the valve based on downstream conditions. So with the CRD, its sensing chamber is the same as the valve chamber itself. So it's set up so that it senses the downstream pressure in its chamber here, and it's a little reverse seated valve. So when you have high pressures on the downstream side, higher than the CRD is set up, it will force the diaphragm up, which causes the stem to go up because it's winning against the spring force, and that will cause this valve to close. So high pressures above the set point of the CRD will cause this valve to close, and when this valve starts to close, it will not allow that 0.1 gallons per minute to pass through. It will force the 0.1 gallons per minute, or a portion of it, onto the bonnet, which will cause this valve to close, okay? Or to regulate close, right? So in that way, it works exactly the same as the CRD function on the red valve, exactly the same. So, and the same way, when you have low downstream pressure here, basically the spring force will then win which allows the stem to travel down, which opens this valve, which allows all that 0.1 gallons per minute off. And it will also start to pull water from the top of the bonnet, which allows the main valve to open. And then you have less pressure losses, so the downstream pressure will rise. Okay? So this one is all about trying to maintain a set downstream pressure. That's all this guy does. It says, so I'm set at 60 psi. If I go above 60 psi, I'm going to start to close. If I start to close, the pilot water is going to be diverted onto here, which will cause the main valve to close. So basically, this pilot valve and the main valve model each other. They follow. So if this one's closing, this one's closing. This one's open, this one's open, right? So that's how they go. And when we talk about opening and closing, it's not like open and close, you know, it's not like all the way through the full range. We're talking modulating around a set point. So if the pressure here, if this is set at trying to maintain a 60 psi downstream pressure, you know, the pressure will maybe drop down to 59, 58, 57, and this will start to do its business, or it will creep up to 61, 62, 63 psi, and again, we'll start to regulate. So we're really hovering around that 60 psi, right? So we're not, you know, very rarely are we ever going to see massive swings in pressure or massive swings in this valve rapidly opening all the way or closing all the way. That's just not going to happen. The only conditions that will happen is if you have a massive main break or you have an 8-alarm fire and every fire hydrant in your system has been opened all at once. Okay? Then you'll see a rapid and sudden drop in the downstream pressure. This valve will go full open. This valve will go full open. Okay? Does that make sense? Okay. And so, again, I haven't talked about this in a minute. So this all just keeps functioning along until your upstream pressure drops. If your upstream pressure is part of the main break or whatever happens, this valve will start to close. When this valve closes, all that water is diverted onto the main valve, which closes this valve. And so this valve could be wide open, saying, I want this valve to be wide open too. If this one's closed, nothing else happens. Okay? So, but the vast majority of time for a pressure sustaining valve, or pressure sustaining, pressure reducing valve like this one, the CRD is going to be in control most of the time. Like, it's going to be doing its thing. And then every now and then you'll have conditions that will affect your upstream pressure. Let's say there was a fire up here or a main break that caused pressures to drop in your upstream side. This one then will take over the valve under those rare conditions. But that's, and you often will see these sort of setups in areas that have changes in elevation. So we really want to have that neighborhood to have the pressure that it needs. And what that means is the lower area is going to have to get its water from another part of the gridiron distribution. So it just says, okay, this is my priority here. I am connected to this downstream neighborhood, but they have other ways of getting water into their neighborhood. And it can't come from here at the expense of this neighborhood. So that's why we put these in instead of just a standard PRV. Now this PRV does not have a backup CRL, okay? So if this CRD fails, it's all hell breaking loose at that point. This CRD fails, this valve fails open. If this fails, it always fails open, which means this valve fails open. Now this valve won't do a darn thing to prevent that from happening unless the upstream pressure drops, okay?
As a result of that.
As a result of that. Let's say the flows are super, super high. We might then see high head losses on the upstream side. But if not, if this is still over 100 psi coming into this valve doesn't care. So we could have massively high pressure downstream, higher than 100 psi, and this valve goes, don't care. It doesn't do anything. As opposed to the CRL, which is here, which's whole purpose is to regulate the valve if this CRD fails. This whole setup is just a pressure reducing valve. It will not sustain upstream pressure, okay? But it has the backup. So we could install a backup CRL on here too, in addition to the CRL that's installed for the sustaining function. So you just have to remember that you can have the same pilot valve performing different functions, and those functions are completely dependent on how they're piloted.
Yeah.
Okay? All right. That's all I gotta say.
Good.